Hi everyone, welcome to this new tutorial where we will be talking about our Proterials pack, which is a pack of procedural materials done for Blender. In this video we will do an overview of how they are created using our what we call building blocks, which are our custom procedural Blender node groups that can be used to create different kinds of materials. Then we will show some examples of how they can be set up to create different kinds of materials and from different complexities. Starting with something quite simple, which is a metal material. Then we will move on into a car paint material, which is a little bit more advanced. And finally we will show a wooden floor. So by the end of the video you should be able to understand how they are created, and you should have the basic knowledge to customize them as you wish and start creating the ones that you need from scratch using our building blocks. Something important to mention before proceeding is that the tutorial aims to someone that already knows a little bit about how to create materials on Blender. You should know what metallic, roughness, normal and transmission means. But other than that, the tutorial should be pretty easy to follow along. So without further ado, let's just get right into it. The first node that you need to know about, and the most important one, is the real principle. This node is an enhanced version of the principle BSDF, which is the most complete shader that Blender currently has. With it you can set up things like the base color, the metalness, the roughness, and many other things. All of these parameters can be found at the very first section of our custom shader node group. As you can see, both of them behave the same way, and those are the similarities between both. Now, our custom shader node group also adds some special shader effects that are under the volume, advanced transmission, and shadow section. The volume one can be perceived if we create a transmissive material, like we are doing right now, and if we connect the volume output into the volume input of the material output node. Now you can see that if I change the color and the density of the effect, you can see how the shader ball has a color that varies according to its volume, which gives us a more realistic result than if we just change the base color of the principal BSDF. So in short, the volume output and section should be used if you are creating transmissive materials and you want to give them a very realistic look. Now the next section is the advanced transmission one. And this section, once it is enabled, will override the principal BSDF. However, it will get the information from the inputs of the principal basic section. So if you want to change the base color of a translucent material, you should go to the base color section of the principal basics to do that. Now this section aims to give you more realistic controls when you are creating transparent and translucent materials. For instance, you can see that you can create a transparent material and have a separate control to change the roughness of just the refractive part of the shader, and that way you can separately control the roughness of the surface. Now I will change the color back to white to show you the next effect, which is the dispersion one. By default it is not enabled because it is quite consuming, but once enabled you can see how the light that is being refracted gets altered by the dispersion effect. Now the next two effects that you can find in these sections are the thin film one and coating, that can be pretty useful when you want to create materials like polycarbonate or a lens glass. Now if we take a look at the shadow of the shader ball, we will see that it looks like an object that is quite opaque. That feeling is caused because there are no caustics, refractive or reflective ones, in the shadows or surrounding the object. Caustics can help you achieve a very realistic render, but they are very heavy to compute. So that is why we decided to add a section to control these effects within the real principal custom shader we created. They will not be physically accurate, but they will be good enough to boost the realism in your renders. Now once this section is enabled, you will see that the shadows start to be controlled. By default it's using the simple method, which can be pretty useful if you are creating glasses for architectural representations. and the color is separated to have better control, but this can be disabled. And you can see that if I change the base color of the principal input, the shadow color will also change. In the simple mode, the only slider that will be working is the transparency one. The other ones, which its name contains the word caustics, will work just if you enable that mode. As most of the inputs that we create for our node groups, changing the different sliders will give you a different output, and they range from 0 being the minimal amount of that effect to 1 to being its maximum. Also, they are named to be very intuitive to use, and you can see how I can easily change the light output amount, the caustic imperfection, and the shadow darkness, for instance. This caustic effect is also linked to the IOR parameter from the principal basics. So if you push the IOR value from there, you will see that it changes the caustic effect. This, however, can be separately adjusted using the IOR boost and the caustic offset sliders. Now, a few more things to add is that you can enable this shadow effect and this caustic effect without the need of enabling the advanced transmission section. So you can create a transmissive material just using the principal basics and the shadow part to control the caustic effect. Now, if you wish to have dispersion on the caustics, you will need to enable that effect in the advanced transmission whether you use it or not. By doing so, you will see that the dispersion effect will be on the caustics, and the output of this effect will vary if you change the caustic sliders. So keep in mind that you can have that dispersion effect whether you use that advanced transmission section or not. Now we can move on to the next part, which are the effects that this real principle shader node group has. Each effect will have a set of parameters to be set up, and it can be enabled using the main toggle. Be aware that you have to enable that sub-effect, for example the low frequency main controller, and you will also have to check how this effect will affect the principal BSDF. So for example, you can affect the roughness and the normal of the principal BSDF at the same time, or choose one of both. Now this effect is quite intuitive because it creates a rough effect over the surface of the object. You can control a low frequency texture and a high frequency one separately. You can change the contrast, the amount of each effect, and the amount that this effect will be affecting the principal BSDF qualities. In this case, I used both textures to create a very rough looking surface. Now keep in mind that naturally some parameters will not be affecting anything if they are not used correctly. As you could saw, when I tried to enable the effect code parameter, it didn't change anything, but that's because there was no code over the principal BSDF. Now, if I turn it on, you can see that this rough effect is affecting the code quality of the principal shader. And another thing to keep in mind is that these effects were created to complement the already existing parameter of the principal BSDF. So you can see that if I change the base roughness or the metalness of the principals, the whole shader will change. And once you are done with editing it, you can enable and disable it at any moment if you wish to see the comparison with your previous shader setup. Now the rest of the effects works in a very similar way. They all have a main enable toggle and a series of parameters to change that particular effect. The brushes one will be pretty useful if you want to create a brushed steel sheet or a sanded area. Some of its main parameters are the orientation randomizer, and the main one is the anisotropy slider. You can see that if I reduce the bump depth, the anisotropy effect will have a significant impact on the surface look. And the ringify slider, when the randomizer is turned off, will let you create ring brushes, and the stretching slider will control how stretched this texture will look. Moving into the next one, which is denting, it is a simpler effect but can let you add that wearing effect over your materials quite easily. The next one is hammering, which emulates a hammered surface, but despite its name, it was used to create the molten chocolate effect and the wavy look of other liquid materials. The next one is crumpling, which was very useful when creating the foil aluminum material and the paper one. And the last one is the organic effect. This last effect was used in many materials, like textured plastics and some fabrics as well. And as you can see, it can give you an output of a very fine organic texture that it can be used to create materials like eco leather or piñatex. Or if you adjust the contrast enough, it will give you a styrofoam looking material. The final section is the output one. In this section you will have an output that previews each effect, so in case you don't understand quite well how it is changing, that output may help you better understand it. As a little recap, you can see that you have many effects that you can intuitively change and stack to create a very complex looking shader. And the principal basics will also change your perception on these effects as well. Now we can move to the next part of the video, which will be talking about the other building blocks that are included. Now I don't want to go in extreme detail as I did with the real principle one, but I want to give you an idea of the different types that we created and how they should be set up to properly create a material and to let you understand how they were created, so you can later adjust them to the needs of your project. These building blocks are currently divided in 5 different types, and they can be found under the building blocks section of the asset browser. The thumbnail and their category should let you have a notion of what they do. The main ones, as we saw, are the shader ones, and the real principle one is the core one. The violet ones are the corresponding to the patterns, and the brick and the weaver are both the main ones in this section. The orange nodes correspond to the texture ones, and all of these textures were quite used in advanced setups. The next one is the masks, and it contains a series of nodes that were used to create certain effects for more advanced material setups. Finally, the data node type are a series of technical nodes that let you have control over an input. For example, you can control the contrast and midpoint, or you can use the triplanar node to project a texture. There is one last type that is included in certain packs, which is a very simple node but quite handy because it contains just color information. Now, the main building block types are definitely the shader, the pattern, and the texture ones. And we can see right now with some examples how they can be set up. As you could see at the beginning of the video, you can create quite complex materials with just the real principles node. We can see in this example that a hammered metal sheet can be created using just the base color, the metalness of the principal basics, and the roughness of it, and then it is just a matter of adjusting the other effects as your liking. If you wish to change the type of metal that is shown, you can use one of the color nodes that is included in the pack to easily change it while preserving the worn look of this material. Now we can move to a more advanced setup, which is, for example, the car paint material. In this case, we see now a bunch of nodes that are being connected. If we take a closer look, we can see a real principal node that is connected to a texture. In this case, I'm using the flakes texture, and we can see that the texture has some outputs that are connected to the real principal one. And then we have a section that contains the texture parameters, where you can change the color, the scale, the amount of the effect. Then there is a texture coordinate section, a pattern input section, and a pattern parameter section. And these last two sections are where the pattern outputs will be connected to and controlled from. We will see that in the next material, but for now we will skip that and we'll focus on the last node of this setup, which is controlling the color of this setup. If we start previewing each node, we can see that this last node is passing the color to the texture node, and this texture node is getting that information to change the texture that is being created. Aside from the color, you can change, for example, the color variation, the overall scale of the effect, the amount of flakes that are being shown, and different properties like the smoothness and the imperfections, for example, of the flakes. Keep in mind that some effects will be more noticeable in a larger scale, and that these textures have a very wide minimum and maximum range because they can be used in different types of materials. Now we can see that these texture nodes, aside from the base color, will also give you other outputs. In this case, this texture gives you a normal, a code normal, and a bump as main outputs. The other outputs will let you see some technical aspects of the node, like in this case the triplanar output will let you see how this triplanar projection is being set up. Now, if we enable back the full shader setup by just connecting the real principle to the material output, we can see that we can also change these parameters while previewing the whole thing. Here I'm just playing again with the color variation, the amount, and the scale of these flakes. And here I move the focus to see a little in detail how some of the effects may be more subtle than others. This is the case for the code normal slider, for example. Now, as a final test in this material, I unplug some of these outputs to let you know that you can plug in just the ones that you need. For example, you can just plug the normal information or whatever output you need. It is just a matter of being creative and using the resources as your liking. One bit more of information about the car paint is that the full and the vehicle pack include color nodes with common color palettes used for car paint materials. So you can easily just drag and drop them into your setup and connect them into the color information. And as an extra, there is a specific color randomizer that is used in the standard car paint material that will output a random color per each object. So you can see that the same material gives two different colors as output. Now we can move to the last material to show a more advanced and complex setup. We can see that this material is created using the real principle shader node, a texture node that in this case is the fiber one, and we can see that it also has a texture parameter section, and in this case the pattern inputs are being used. You can see that the toggle is turned on and the outputs of the pattern are being connected to the inputs of the texture. This pattern node also has its own texture coordinate parameters, and the objective of this node is to feed in some mapping information to the texture node and provide some maps to affect the texture and be controlled from the texture node. If we preview the texture coordinate main output node from this pattern node, we can see that it provides that mapping information, and the UV randomizers are there for creating that randomization that can be useful in materials like this one. It is worth mentioning that each node will have its own texture coordinates, so you can see that the triplanar projection of this pattern is by default dynamic, but if we enable the static option, it will freeze and change accordingly to the object transformation. Now let's see a little more in detail some of the main parameters of the pattern nodes. You can see that they are quite intuitive to use, and it is just a matter of playing a little bit with them. While changing any of these inputs, you will also be changing any of the outputs of this pattern, and this will end up affecting the texture where it is connected to. Just for the sake of demonstration, I will just unplug all of them, and you can see that the texture now it doesn't have any pattern and it can be used freely. With this fiber texture alone, you can create a solid block of wood. But when you plug in any of the patterns, you can create a more complex setup. In this case, I decided to use another of the patterns that are provided to you, which is the brick pattern. If I adjust the scale of it and connect its outputs to the texture, you can see that the same texture now gives us another result. And at any moment, you can play with any of the parameters to get the desired look that you are needing for your project. Here I'm quickly showing you how you can change all the different parameters as you need. You can change the color of the texture, the amount of waves, the contrast that it has, the strength of the normal output, and I do also adjust some things from the Real Principle shader. By doing all those adjustments, you can clearly see how you can intuitively create different looking wooden floor materials. Or even if you adjust them enough, you can use that material to create the base of a fabric material by just changing the scale of the pattern, for example. Now, the last bit of information in this material is that the other map information from the pattern node that is being fed into the texture node can be controlled using the inputs in the pattern parameters section. By adjusting these sliders, you can add some color randomization to each module, adjust the separation of the pattern, or the curvature that it has using the cavities map. Now, if you are watching and did this mark, well, first of all, congratulations, because you are very studious. And here is a last example of a different kind of setup. The industrial floor material doesn't necessarily follow the same principles as I mentioned in the whole video, but it is a good example of being creative and using the different nodes that are provided to create the effect that you need. In this case, that texture was created using the polygon mask, and I plugged in a weaver pattern to create that type repetition. You can see that I can create a quite complex pattern with just two nodes connected, and that setup can be later combined with a more traditional Blender setup. You can see that I'm just adjusting a little bit the tiling and playing around with the shape of the polygon just to show you that you can do that. But then we can see that that mask is used to create the different outputs that the material needs. For example, part of the mask was used to create the albedo information, the roughness, and the bump using traditional Blender nodes. To sum up, through the video we learned that there are different types of building blocks. The main ones are the shader, pattern, and texture node groups, and you can create materials with different complexities of setups. The most basic one is using just the Real Principle shader. That is the setup that all the materials in the Elemental pack use, and some examples are the velvet one, the rough metal, wax, rough plastics, and so on. Then a little more advanced is when you plug in a texture to the Real Principle, and some of the main examples are the wood materials, the galvanized metal, and the polished stone material. And a more complex one is when you plug in a pattern to a texture, and that texture is then fed into the Real Principle. And it is a matter of just playing around with them and enjoying creating new materials for your project. I hope that with this information you will be able to adjust the materials that are provided and create the ones that you need for your project. We would love to see your creations with it, and we really hope you have fun using them. If you enjoyed this tutorial, we will really appreciate if you give us a like, subscribe, and spread the word about our project. For now, that's it for this video. See you in the next one. Saludos.